I'm still in love with our custom house that we built a couple of years ago, but my least favorite part was this dark windowless hallway. So I decided to put in a little feature that will let in the light. Let's go see how I did it.
This video is sponsored by DAP Products. We have a pretty simple color palette throughout the house, so I didn't want to add too much extra color down here, but I knew I needed something to add a little bit of visual interest, and obviously we needed to introduce some more light.
Before I can get started laying out my design on the wall, I need to tackle this smoke detector. It's kind of an eyesore and it's going to be in the way of my panels. So I'm going to try to just move it straight above where it is, but put it up on the ceiling.
Make sure you consult with a licensed electrician before you touch any of the wiring anywhere in your home.
I need to start laying out my design for the panels on the wall, as well as for the spacer frame that's going to go behind it. The best way to do that is to use a laser level and a pencil. I went ahead and found the center of the width of the wall. And an interesting fact about MDF panels is that they actually come in 48 by 97 inch panels instead of a standard 4 by 8. I want to recess my LED strips, I think 3 inches from the edge. That way you won't see the strips when you're walking by at an angle. So that means the outer dimensions of my spacer frame needs to be 43 inches wide and 91 inches tall.
For the spacer frame, I decided to use 1/2 inch quarter round PVC molding because it was the cheapest material by the foot that I could find. The rounded side wasn't going to be an issue because I could just turn that towards the inside of the frame.
This is one of those projects that a good laser level is worth its weight in gold. And this segment of the video is not sponsored, but I really like this Bosch green laser. I think it works better in low light situations like down a dark hallway.
To attach the molding pieces of the spacer frame to the drywall, I decided to use DAP HD Max construction adhesive. It's incredibly strong, creating a permanent bond, but it also has a high initial tack, which means after I applied a bead of the HD Max to the trim, I could easily press it up against the wall and not worry about the piece sliding while the adhesive dried. To give myself just a little bit more security, I also added 23 gauge pin nails. Liking what you see? Tag that like button down below. And if you haven't yet, make sure you subscribe as well. Next, it was time to tackle the MDF panels themselves. Even at only 1/2 inch thick, these panels are ridiculously heavy. I totally lucked out, and the dimensions of my hallway allowed me to use 3 full-size sheets without having to make any cuts.
I'm getting ready to sand these MDF sheets to get them ready for paint. Just a little reminder, whenever you're working with a manufactured product like MDF and particle board, it's a good idea to remember your respirator. You don't want all that stuff getting into your lungs.
After sanding, the real adventure of trying to move all 3 sheets by myself began. As I mentioned, these things are so stinking heavy. Each sheet weighs over 65 pounds, and spread over 8 feet in length, they can become pretty unwieldy. If you're in a situation like this by yourself and you're not Superman, a couple of tips I have are, first, to wear safety seal shoes so you can set the material on top of your foot. And secondly, consider getting a sheet carrier. I have one from Craig that I really like. I'll link both my boots from Timberland Pro and the sheet carrier from Craig in the description box.
Paint time, well, more accurately, primer time. MDF it really needs primer. It's one of those materials that it's super important to prime. It's very thirsty, and if I was to go ahead and start spraying paint, it would absorb it unevenly and I would get a bunch of blotchiness. I'd also waste a lot of expensive product. So we are going to start with probably 2 coats of primer, and I want to make sure to concentrate on these edges because they are the thirstiest spot of the entire sheet, and I want to make sure I get a nice good coverage.
After primer, I applied 3 coats of the same trim paint that we used on our baseboards and doors.
I was just getting ready to start cutting into the wall to run my wiring when Bryce reminded me of 2 things. First of all, that's a shear wall. So it's not just drywall with hollow wall behind it. It's full OSB behind the drywall. So running wiring behind that's not going to be very fun. He also reminded me that the wall behind the fireplace on the opposite side is empty. So I can access the wall through the back side. We just have to pull the fireplace out of the way. Time to start wiring up my driver and getting my whole LED system set up. I'll be honest, this is my first time setting up an LED system. So I am going to recommend that you go and get some expert information from people who know a little bit more in this specific area than I do before you start your own project. A video that was very helpful to me was actually created by my buddy Brad from Fix This Build That. He has an entire intro primer to LED systems. He talks about the different types, gives his recommendations for ones to purchase depending on your application. He also talks a little bit about controllers and drivers and power systems and things like that. So I will leave a link in the description box so you can check out his whole video once you're done watching this one. Meanwhile, I have done tons of research for my specific application and I feel pretty confident in my plan. So I'm going to show you what I'm doing. I live in the United States, and so that means that the power that runs through my walls is 110 volt and an AC current. LEDs work on a DC current, the same kind that comes from a battery, and the specific type of LEDs that I used run on 12 volts. So that means I'm going to have to convert the power that I am getting from the outlet in my wall to work with the LEDs. So I bought a 150 watt magnetic LED driver. This will convert the 110 AC power into the 12 volt DC that I need to power the LEDs. This one is large and it was kind of expensive, but I needed that to be able to power the amount of LED strip that I'm running. Luckily, we already have power in the fireplace. We installed a 2-gang outlet while we were building it to power the electric fireplace. So I have power for my DC transformer, but it is a 3-prong 110 plug. So that means I'm going to need to wire a 3-prong plug onto my transformer so I can easily plug it into this outlet. So I need a dimmer. And because the outlet is going to be behind our installed fireplace, I also need a way to turn the power on and off without having to take the fireplace out every time. Bryce had a great idea to use one of these. This is a dimmer control module for an old ceiling fan. If I wire this in after our driver, I will be able to control the LEDs using a remote. Each panel is going to have its own independent strip of LEDs that will come back to the driver. That means I need to hook up 3 different whips or 3 different lengths of wire that will come outbound from the driver, and then I can run through the wall, poke out the other side, and connect to the end of the LED strips.
The term for this technique is wiring in parallel, which allows consistent amperage to be provided for each LED strip. This becomes especially important when you're running long lengths of LED lights. LEDs come in a huge array of configurations. Generally, the closer together each individual LED is to the next one, or the more LEDs per inch the strip has, the more smooth and consistent the beam of light will appear. You can find links to all the products that I used in my particular setup in the description box. The strips are about 7/16 of an inch wide, so just under ½ an inch, which works perfectly with the ½ inch quarter round trim I used for the inner frame. I chose LED strips that project a warm white 3000K color to match the rest of the lighting down the hallway. They also come with a pre-applied adhesive backing. To light up all 4 sides, each panel required about 23 feet of LEDs. But the standard length for most LED strips is 16.4 feet. Luckily, you can easily connect strips together by cutting across the copper dots, which indicate the ending and the beginning of the circuits. You then slide the ends of both strips into a connector, which gets compressed, connecting the circuit and holding the strips together. Just keep in mind that you will lose a little bit of amperage over long lengths. So depending on the particular LED strips you use and your power source, you might be limited in length. This would result in lights that were very, very bright in the beginning of the LED strip and dimmed towards the end. At this point, I was ready to attach my power transformer to the wall inside the fireplace. On the opposite side of the wall, I used a 1/2-inch spade bit to drill through the corner just inside of the frame. I then ran the 3 supply wires or whips from the transformer through the wall to each panel and connected them to the individual LED strips. I used crimp tubes to make my connection, but you have a few different options. To make extra sure that the ends of my LEDs wouldn't come loose over time, I added a bead of hot glue.
With this last panel, I actually had 2 studs I had to get through. It was a little complicated. So I ended up cutting a little viewing window, which I just screwed back in place, but now I have this, ugly drywall. So I am going to clean it up with some fast dry spackling from DAP. This is my go-to spackle because it dries really, really quickly, and it also allows you to fill wider gaps than you can normally fill with typical spackle. The LEDs are pretty much done, so I am ready to begin attaching my pre-painted panels to the wall. As you can imagine, full sheets of MDF are very heavy, and although we are lucky enough to have OSB behind the drywall on this wall, I still want to make sure that I can distribute all that weight and have an easy way to get the panels up and mounted onto the wall. I decided the easiest way is going to be using French cleats. You can make French cleats yourself, they're pretty simple, but because I'm working with a really shallow margin, less than 1/2 inch, I figured my best option would be to go with the manufactured aluminum type of French cleats. So once I got her 12 inches long, and I think they are rated for 70 pounds each. Each panel is going to get 2, one towards the top and one towards the bottom. So that should more than accommodate, the weight of each panel.
Before I could start mounting my French cleats to the wall, I actually needed to make a little step-off block that would go between the cleat and the drywall. This would allow the cleat and ultimately the MDF panels to sit out 1/2 inch away from the wall, accommodating that 1/2 inch inner frame. I used my handy dandy laser level and 2-inch screws to attach the blocks and the cleats to the wall. If your wall doesn't happen to have OSB backing like mine does, you would need to use some heavy-duty drywall anchors.
It's time to get the panels up on the wall, and I have an experiment I want to try to make sure that they are aligned perfectly. It's very, very important that those 2 sides of the French cleat are lined up perfectly so the weight is distributed evenly between the top and the bottom one. Also, because my panels are 49 inches wide and I'm mounting them in the middle, if my French cleats are not perfectly level, flat with the horizon, if they're tilted a little bit, my entire panel is going to be cocked. What I plan on doing is sticking both sides of the cleat together, the panel side inserting it next to the wall side that's already installed. I then will add a piece of thin double-sided tape to the front of the panel cleat. We then will lift the panel in place, help align the bottom horizontal line by sitting it on a block, and then we can press the panel up against those cleats, and hopefully the double-sided tape will stick to the back of the panel. So all we have to do is then carefully lift the panel off and the cleats will be stuck in place where they need to be attached. Hey, it worked! It worked! Okay, we're good.
With half of the French cleats stuck to the back of the MDF panels, all that was needed to make a tight connection was to pre-drill and attach the cleats using the screws that came included with the kit. Next, the 2 of us, but mostly Bryce, lifted the panels into place and set them inside the French cleats.
We just got all 3 panels up on the wall, and we almost forgot there is an outlet behind this middle panel. So we need to extend it, bring it outward. I purchased one of these guys. This is an outlet box extension. It protects the sides of the outlet as you pull it away from the wall. Shut off the power, obviously. We're going to take out this outlet. We're going to disconnect it. We are going to install the extension box on the face of the MDF panel, and then we can reinstall the outlet and add our faceplate, all that fun stuff, to the face, and we will be safe and protected from any accidental contact all around our outlet.
The French cleats allow for a little bit of side-to-side movement, so I was able to get a consistent 3-inch spacing between the panels by giving each one a little tap. Ready to see the final result? Just for a reminder, here's the before, and here is my hallway now. I love that the brightness of the LED lights is adjustable.
If I was going to help somebody do this project in their house, I might recommend setting back the LEDs just a little bit more. I don't think 3 inches was quite deep enough. It's hard to see on camera, but if you walk by at just the right angle, you can see the LED strips for just a split second. Not a big deal, but you know, the perfectionist in me would probably do it differently the next time.
We'll probably do something to jazz up these boring flat panel doors in the future, but in the meantime, I think the hallway has received a major upgrade. If you want to learn more about the DIY modern house that we built, check out our full Building Modern on a Budget series. And if you like other types of DIY content, check out this video as well. Have you ever worked with LEDs before? If so, give me your tips down in the comments. And as always, thanks for watching, guys.